So we will be talking about measures of location and measures of variability. Uh, Now, if we compute these measures using sample data, we call them sample statistics. So we have a distinction between population and sample in statistics. So we have sample statistics for those measures which are computed from the sample. And if these measures are computed for data from a population, they are called population parameters. A sample statistic is referred to as the point estimator of the corresponding population parameter. So let us have a distinction between sample and population. I want to ask you if what do you think is the difference between sample and population? Any idea?
So, a population is the entire group, whereas a sample is like a specific context-based, portion from that population.
Right. Yeah, you are right that uh, population is the entire group or everyone or everything which is there is in the population. So population is complete, and population has everything and everyone which is studied or analyzed or discussed. While a sample is a subset of population, sample is a part of population, a small part of population, and sample is collected from population. So sample contains some population data, and population contains the entire data which is there. When we study a population completely, we call it a census. So if we are recording observations on each and every element in the population, we call it a census. And when we are not in a position to collect information or observations on everyone in the population, but we have some limitations of time and money, and then we are forced to choose only a small part of population. We call it sample, and what our goal is in this whole exercise is to use the information contained in the sample to say something about population. So we can have a sample survey. We can, in social sciences, we can do a sample, and we can do a census for the entire population. But generally, what we do is a sample, and we are concerned with some characteristics of population, and we want to estimate them using sample. So suppose we want to know population mean. So population mean, generally represented by mu, is a population parameter. while sample mean, which is represented by X bar, is a sample statistic. So population mean is a population parameter and sample mean is sample statistic. And this concept of estimator links sample the concept of mu and X bar. So we call our X bar as a point estimator of mu. So our X bar, which is a sample statistic, is a point estimator of mu, right? So if I ask you what is an estimator, what would be your answer? An estimator.
Basically, it's generalizing some facts about the entire population because we're saying that, the sample statistic is the point estimator for the corresponding population parameter. So, whatever data we draw from that particular subset is representative for the entire group in question.
So,
Yeah.
so if I say it, my understanding of estimator is basically um, a rule or basically a precondition on which we distinguish the data, given data set. Um,
Right.
yeah,
Yeah.
basically a point of distinction or in a rule or a chain rule for calculating a set of data and analyzing that set.
Distinguishing between what exactly?
So no, I was just asking about what do you think is an estimator?
Yeah, so what that is what I'm saying. Estimator may be uh, that forms a basis for a given data set, like basically a rule on which we quantify a data.
All right. All right. So so yeah, you are right. That an estimator is something that estimates another thing. So this is a population and this is a sample, and we are trying to estimate something about population using some other thing, and we call that thing a estimator. So this is an estimator. So sample mean is the estimator of population mean. That means sample mean contains information which can take us to population mean. That means sample mean is the estimator of population mean. So if somebody asks you how to define an estimator, you would say an estimator is some formula, some rule, some method which allows us uh, to say something about a population parameter, right? So there should be some formula, some rule, some method, and an estimator is that rule or method through which we can say something about a population parameter, right? So sample mean has some information, has a lot of information about population mean, although we have only a subset of population in the data. But still, because sample is also collected from the population, so it has that vital information. The only thing is we have to we have to know some methods, some formulas, some rules that allows us, or that will help us reach population parameters from the sample statistics, right? So that rule is the estimator. And when I say point estimator, uh, uh, when we are using the word point, it means that if there is a single number, for example 24.3, it's a point, right? You can understand it as a point. And when you have a range of numbers, for example 24 to 25, then everything in the middle of 24 and 25 is in this range. We call it interval. So we can have interval estimators, we can have point estimators, but when we talk about sample mean x bar and population mean mu, we are talking about point estimators because both are points. There is a number called mu and there is a number called x bar. So in that sense, we understand this point estimator here. So you can think of population uh, being characteristics of all students, all UG students of India. And suppose you are collecting, you cannot go to all UG students of India and ask them about their study hours per week, right? About their self-study hours per week, right? So there should be some population mean self-study hours per week for all students of India. And we cannot calculate that mu because it's difficult to reach out to all these students because there are a lot of them and they are all around India, and it's difficult to reach each one of them if we are doing some sort of study in which we want to know something about what is the mean self-study hours of students, UG students of India. So what you would do is you would go to some parts of India, not all, where some universities, and you would choose your universities and geographical areas intelligently. That's you would do your sampling properly, which is another big topic in statistics. So how to do sampling? Uh, so if you are now, suppose you know that your population is uh, say 10 crores, okay, 1 crore, suppose. So this is just an suppose you have an idea that what is the population size, suppose it is 1 crore, right? Then if you are going to say 1000 students from all over India, from all the universities, and many universities in different parts of India, and you are sampling some students and collecting information about how much self study per week they do. So that would be your sample, and you would be using your mean x bar, mean of the sample, how many, what is the mean self-study hours of students in your sample, which is just 1000 students. And you would use that information to say something about population mean, which is unknown. You don't know what is that, how much is that. That's what you want to estimate. So to get an estimate of mu, you will use your x bar. So your x bar is the point estimator of mu, right? So that's how you can understand this whole population sample thing and estimator thing, right? So let's talk about measures of location. Uh, what is it? What are these measures? Location means the position or where is something situated. So we will talk about mean, median, mode, weighted mean, geometric mean, percentiles, quartiles. These are all positional statistics, right? So these are measures of locations, where something is located. right? So if you have a number line, suppose, and there are many numbers here, say 5, 10, 15, 20, 25, 30, and suppose this is uh, this is about any variable x, so x can take these values, and if you collect a sample on x, suppose, and there are 100 observations here, so there will be 100 numbers which you can think between 5 and 30, but when you calculate the mean, it might be around say 12, or it is 12, suppose. So the mean is 12. So we see the position of 12, right? So the numbers are starting from 5 ending at 30, and we have numbers all over the place, but when you calculate a mean, you would have one number 12, which is the mean, and you can locate it on the number line. Okay, this is the mean in 12, and here it is. So we got the position of something called mean, which is located or situated at some point on the number line. You can see what is the distribution to the right of 12, how much values might be there to the left of 12, where is the density high, where is the density low, etc., etc. A lot of things creep up from here onwards, right? So the first thing first, we need to know some locational measures, and mean is one of them. You can think of median and mode in the same way. Let us take them one by one. So mean is the most commonly used measure of location, and it provides a measure of central location. Central, not central in the sense that with respect to concentration, right? So you have in your body, you have your center of gravity, right? So that's a sort of center, right? Similarly, if there is some distribution of let us say mass, then you can see if there is it is more dense to the left and less dense to the right, then the mean is going to be in the dense part, right? So that's also a center. It's not center per se, but it's a center in the sense that it is talking about how dense the values are. So in that sense, we are saying central location. It doesn't need to be in the center of the range of the data, but it could be central in the sense that it provides us where is the center, which might not be in the center per se, as we understand the word. So central with reference to density and with reference to center of mass, center of gravity, sort of thing. So we will understand it better as we move. Basically, if we take the average of all the data values, we call it a mean, right? And we use x bar for notation, and it is a point estimator in the sense that it is a number like 12.2, and it is an estimator of population mean mu. So population mean might be 13.5 and our sample mean might be 12.2, but it is an estimator of 13.5. So using some statistics. So that's what statistics is all about. We have a sample mean of 12.2, and we don't know that population mean is 13.5, but we will use this sample mean and we'll be able to say something about population mean. So that's what statistics do, right? So we have a lot of testing, probability theory and hypothesis testing and all those statistical procedures which help us to say something about the unknowns like population mean, which is a population parameter, using things which are known like sample mean. So that's the mean. We can calculate it in a very simple way. We just add all the observations and divide by number of observations, and what we get is the mean of of a variable x. So if we have a variable, and then if we want to calculate the mean, we will add all the numbers, which is 20, and we divide it by number of numbers, 5, and 4 is the mean, right? If we write the range of the numbers, it would be 2, 3, 4, 5, 6, 7, right? And if you locate 4, you can see it's not exactly in the center as far as the range is concerned, right? But yet mean is a measure of central tendency. So where is the center of this whole data set? It's at 4, which might not be geographically in the center. Population mean is calculated using data in the population. So if this is the population, so that there are thousands and thousands of numbers here, and then you add all those thousands of numbers, summation xi, and then you divide it by how many numbers are there, right? Maybe 100,000 numbers, right? And what you get is the population mean. So generally population mean is unknown. We don't know what is the population mean, but we have an idea using this formula that many times we know population size. So we know population size capital N, but we don't know the mean because we don't know all the observations on X, right? So that's generally the case. Anyways, this is the concept. If you add all the observations, all the data in the population on a given variable X, you can calculate the population mean of that variable X and denote it by mu, like this. So the formula is same, except that we have a small n in the denominator of sample mean, and we have a capital N in the denominator of population mean. The rest is same. So suppose we have apartment data, and there are 70 efficiency apartments, and they were randomly sampled in a college town, and the monthly rents for these apartments are listed below. So these are all rents, and these are monthly rents, all of these, and there are 70 rents of 70 apartments, and it's a sample, right? So we have already assumed it's a sample, right? And if we add all these numbers, we will call it summation xi, and then divide it by 70, what we will get is the sample mean. So that is what is done here. If we add all of them, 41,356 is the sum of apartment rents, and because there are 70 apartments, we divided by 70, what we get is 590. So this is the average rent or sample mean of X, where X is apartment rents, right? So we got our X bar like this. Then another measure of location is median. Median is the value in the middle when you arrange your data in ascending order. So if you have a data set which has extreme values, the median is preferred measure. So median is preferred to mean. And median is reported for income, annual income, and property value data. So if you have property value data, if you have income data, you can use median. Median is better than mean in that case. It depends on what is our goal to choose between median and mean. Both are the measures of location, of central tendency of a data set. but we have to see which one is suiting better. So generally, it's the question of extreme values, right? So we will talk about this extreme values. First of all, let us see how median is calculated. So what you have to do is arrange data in ascending order. So if this is your data, then you will write the smallest number first, and then you will write these numbers in ascending order: 12, 14, 18, 19, 26, 27, 27, and there are 7 observations. So we have odd number of observations. 7 is the odd number. And then we can see where is the middle of this whole set of data. So 3 numbers to the left of 19, 3 numbers to the right of 19. So 19 is the median because 19 is in the middle, right? If you have even number of observations, then there are 2 numbers in the middle. In that case, you have to take the average of the 2 numbers. So 19 plus 26 divided by 2. So 22.5 is the median. So this is our apartment rents data. You can calculate the median if you arrange them in ascending order. So they have arranged it in ascending order, starting from 525 to 715, and it's moving in ascending order. You can see the numbers. Because there are 70 numbers here, so it's even number of numbers. 70 is even. So in that case, you have to take the middle 2 numbers. So the middle 2 numbers are going to be the 35th and 36th numbers. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 numbers in each row. And if you reach the middle, 10, 20, 30, and then 31, 32, 33, 34, 35. This is the 35th number. And this is the 36th number. These 2 numbers are right in the middle. There are as many numbers on the left as there are on the right of these 2 numbers. So you can just take the average of these 2 numbers, which is again the same number because they are both same. So 575 is the median of apartment rents. Now coming to the point that extreme values, when we have extreme values, why is median preferred? Why is it preferred? So let us take some numbers. For example, we have a variable x and a variable y, and then variable x is 2, 5, 12, 31. $50. Right? And suppose we have numbers like 18, 22, 22, 18, 20. Suppose these are the numbers. So if you want to calculate a measure of central location or tendency in these two, for these two variables, you can calculate mean and median both. And in case of x, tell me what is the median and what is the mean. So x bar is, in this case, 20. So so let me change it. It's not good representation. Let me make it like this. So in this case, again, the mean is 20 and the median is 10, 10, 12, so 12, right? In case of y, the mean is 20, while the median is 18, 18, 20, right? So when we don't have any extreme values in y, you can see median and mean are doing a good job. Both are doing good job, and mean can be thought of as okay here. But in this case, the mean is 20, while if you see the numbers here, there is one number which is extreme value 56, which is huge as compared to other four values which are 10, 12, 10, 12, right? So in this case, if you take the mean of 20, it will not be a good representation of the x data, because most of the numbers are 10, 12, 10, 12, but because there is a big number, so our mean is affected by that big number, and we reached something like 20, but actually our data is revolving around 10, 12. So median, which is 12, is a better representation of the data on x. So it's better to take the median when we have extreme values in the data, right? So if you want to understand, for example, your goal is to see what numbers would be there in x, and you have not seen these numbers, and somebody told you that it's 20. So you would say, okay, 20 is the mean, so values would be around 20, like 22, 18, like that. And if you are asked to pick a number randomly without knowing from here, it's more than probable that you will pick a 12 or a 10. So you'd be surprised what you picked, right? Because there is only one number which is big. Even if you pick 56, you'll be surprised again, right? But here you would not be surprised, and if you are picking one number, it would be 18, 20, or 22. So for y, mean and median both are good representatives, while for x, median is better, because if somebody told you what is the median, you would have a better idea of what you're going to pick if you are asked to pick a number without knowing the number. So when we have extreme values in a data set, median is a preferred measure. of central location. Right. Why is it reported for annual income? Can anyone explain this? Why median is better for annual income?
So if we talk about India, it is because we have extreme values in hand. We don't have a like there are lots and lots of extreme values when we consider income.
Right. Right. So because there are huge income inequalities in the world and in India also, so there are people who are very poor, suffering from hunger, no job, no food, no house, and there are people who are billionaires, and there is an extreme income inequality in the world. So if or any place in the world, there is always this is always the case that the income data is skewed, right? So we have some people who have very low income, we have some people who have very high income, and so in that case, it's better if you are talking about not something as big as India. If you're talking about, say, students of your class and their family incomes, and you're reporting their annual family incomes for the students of your class, it might be possible that it is skewed and some people having very low and some people having very high income. So in that case, it is better to report median as a measure of location rather than the mean, because mean is affected by extreme values and median is not affected by extreme values. That's why annual income data is reported, median is reported for these. Similar is the case with property value. Property value is also, there are properties which have a very, very high value and there are properties which have a very low value. So again, this is skewed and uh, it's better to report median rather than the mean to get an understanding of the central location. All right, so this is median. Uh, that's how we calculate median. So we'll talk more about mean and weighted mean and all those things later. Any question from today? If you have any question, you can ask.
No, sir.
All right, so